Good day everyone, we are Group Cyber Genesis and today we will present Arduino Project 13 Motor Fan. Our group members are Nanjeri Nashtiglao, our leader, myself, Marcia Marpuntillo, and John Michael Pojeda. This project is presented to our professor, Dr. Earl Marquez Albina, for our subject Application Development and Emerging Technologies. In this Arduino project, we built a small fan using 130 DC motor and a relay from the Arduino starter kit. A relay is an electrically operated switch that allows the Arduino to control devices that require higher voltage or current that it can handle directly. For this project, we also included a push button to turn the fan on or off manually, and an RGB LED to indicate the system status. This project demonstrates how to use Arduino to control a motor safely and can be applied in real-life systems like cooling devices or automated appliances. The components we used for this activity are: first, Arduino Uno board to control the circuit, second, breadboard to assemble the connections, third, jumper wires to link all components, fourth, RGB LED indicates system status, on or off. Next, push button used to manually control the fan. Resistor protects the LEDs and circuit from excessive current. Relay switches the motor on or off safely. 130 DC motor, the motor that powers the fan. And lastly, fan blade attached to the motor to produce airflow. With these components, we successfully built a motorized fan that can be controlled through a push button and monitored with an RGB LED indicator.
Good day. So here's the source code for activity number 13. So now the header, we have the header here. The we are going to initialize the button pin and the relay pin into pin 2 and pin 3. We are going to have our relay state into high. Then we're going to initialize the button state, initialize the last button state into low. And then we have these two long variable, long last debounce time and long debounce delay. This is just to check if the button bounce is stable enough. So let's see. This is as I said earlier, we're going to initialize the pin. Then we're going to save the variable of each component's state. So the relay state is high. We have the initial the button state, and then we have the last button state, which is initialized into low. Next, so why do we need the two variables here so that we can be stable. Because when the signals are received by Arduino itself, the program does not operate on them immediately. It tests first if the signal is correct and then waits for a certain time to confirm. If the signal is correct, the program will be operating accordingly. So essentially, if the reading is not equal to the button state, so since the button state is low, our button state would be reading, will be equal to reading. So now we will now see that our button state will be high. Then if the button state is high, then we will switch the state of the relay. So now it will go from high to low. Then after that, we are going to write it on the relay pin, write the state of the relay, and then the the previous reading that we have will be saved in the last button state variable. And then we will going to save that true after the next loop.
So I transfer the circuitry to a proper breadboard, and as you can see, if I press this push button, the motor spins. Pressing it again, it stops. You'll notice that you're going to hear a ticking sound. That's not coming from the push button actually, that's from the relay activating the magnet inside it with electricity. And as we turn on, the LED also lights up.